There's a distinct advantage when you're working in 3D. You can see where items are placed, and if you're modeling accurately, you can make sure that everything fits into the model. Down the road, this will help you reduce errors and conflicts, but sometimes the model can get pretty congested and hard to read. AutoCAD MEP includes a sophisticated interference detection tool, so let's take a look at how it works. The interference detection tool can be found on any of the engineering workspaces on the Analyze tab. This palette lets you compare building objects, building elements, and even AutoCAD solids. Since this tool is a palette, it can remain up on the screen or docked as needed. To run the tool and look for interferences between MEP objects, look under the MEP Objects section. Check the cable tray, conduit, duct, hanger, and pipe options. Make sure that none of the building elements are checked. For a clearance check, leave this off. When turned on, you can specify a distance around all objects to be used as a clearance area. This is a nice feature if you know you're going to have insulation and other items that may not have been modeled. Look at Settings. This first option lets you keep the mass element that is created to represent the interference. I usually leave this off so I don't add a bunch of extra elements in the drawing, but turn it on if you want to see the interferences after you leave this command. Interferences can be tagged and tracked. Turn this one on if you want to print a drawing and report to go with the interferences. If an interference is detected at a wall, you can tell the program to place an opening symbol. This lets the owner of the wall know that they need to add an opening to their elements to help with the clearance. I want to point out that the tool works with XREFs as well. All of these models are referenced in, so you can create a coordination drawing that contains all of the discipline constructs and check the entire project at once. Pick the Start Interference Analysis tool at the bottom of the palette. This may take a few minutes or longer depending on how well you've already coordinated. After the analysis is finished, a list of interferences will appear. Pick the first one on the list. The program will zoom to the area where the interference occurs, so now you know what you need to fix. Right-click on the error in the palette. You get 4 options. Zoom to, which zooms into the area. Select All. This highlights all of the interferences in the report. Clear All. This clears the highlighted interferences. And Delete. This removes the mass element that indicates where the interference is located. Go back and select Yes for clearance checks. Set each item to 1 inch. When finished, start the analysis again. In this project, this can take anywhere from a few seconds to a couple of minutes. But clearances can add to that time substantially. So I usually run a hard detection first, fix the errors, and then use clearances once I've worked out most of the hard clashes. When the analysis is finished, clearances are now also included. Once you're finished, you can close the dialog. A ribbon is displayed whenever the tool is being used. Note that you can continue to use the tool even if the palette is closed. You can cycle through clashes, zoom to and select clashes, add tags and symbols, and reopen the palette. Choose Close from the ribbon to exit the analysis. You may get a warning based on your settings about the deleted mass elements. This displays if the Keep Mass Interference element is turned off. Select Yes, and you've checked your model. This simple task can help you resolve conflicts and produce a better quality set of documents, as long as you're leveraging the object-based tools.